So I'm working on some BMW motorcycle cylinder heads at the moment. My customer was doing this work himself. He's removed the valve guides, but unfortunately he dropped this cylinder head and it landed on top of an hammer actually, and he's put this little groove in it there. So what I've got to do is I'm just gonna tickle this bit out with a grinder and then just run a little bit of weld across there, and then reface this head, fit the guides, cut the seats, and then it's ready to give back to him. So that's the head welded up. So what I'm going to do now is fit the guides on both cylinder heads, and then I'll reface both. So next job for me on the BMW heads is to fit the valve guides. I've set the angle up on the valve guide press. So I've measured the guides to make sure I've got the right interference fit, and that's it. We'll press them in. So I'm putting a bit of oil down the guide board just so it doesn't pull on the aluminium. That's one done, or one side of one done. So now I'm doing the inlet side, so I've put a bigger collar on there to sit on the seat. Once again, plenty of lube. The last cylinder head. I've not had to measure the valve guide depth because it's got a retaining clip on there, so that makes that a bit easier. And that's it. That's all 4 valve guides in. So what I'm going to do now before I cut the seats is I'm going to reface them, but the last thing I did was cast iron, so I'm going to wash the machine down, swap the stones over for the diamond, and then we'll reface both them heads. So the next thing on the BMW motorbike cylinder heads is to reface them. I've got the first one mounted, which is the one that I've welded. I want to skim this one first because I want to know that where I've welded it, if it's distorted it a little bit lower, and I need to skim a little bit more off than what I think to get it flat, then I can match the second head, which is here, with the same amount. So I've plugged it in, I've brought the diamond down in the machine. So basically when we're machining with cast iron, we use these stone segments that, I don't know if the GoPro's picking it up, but there's about 12 stone segments there. And when we're doing aluminium, we then drop the cutter, which is that there. So the machine runs quite fast, and I've already set the depth, so I know that it's just touching there. And then to lower the head of the machine, I just have to turn this here. So I don't want to go too much. And then I don't want to go too fast either, so just a nice steady cut across the top. And a bit more. You can just see it's just starting to polish up there. You can hear it then as well. Just see it's where it's polishing the top of it up. So another cut. It's a bit tricky one-handed. Right, I'm going to carry on skimming this. I'll show you what it looks like finished. So this is the last seat I've got to cut on this pair of BMW cylinder heads. This is a 45 degree I'm putting on this one. I've let my customer know that these are ready, so they're all skimmed, guides in, the bit of damage is repaired there. So I'm going to cut this last seat, get them in the wash, and then they're ready for him to collect. The next job that I'm doing today is these Harley Davidson cylinder heads. We removed the seats for our customer who was going to put his own guides and seats in. He's got the guides in, but he couldn't get the seats to fit. So after some slight measuring, it's basically because the interference fit is too much. There's basically a 10 thou interference, so we need to counter bore the cylinder head out to reduce the size of the interference fit to get the seats in, and then I'm going to freeze the seat and then drive them in, lock them in with ceramic, and they'll be good to go. The only thing that I'm a little bit worried about is because there's only sort of 5 thou coming out, 6 thou coming out of the seat, it means that we're only going to be able to take 3 thou off each side. So I'm hoping that these guides are good and that it isn't slightly offset too much, so it won't counter bore correctly. So one of the important things to do when doing valve seat installation is to make sure that the tooling is set correctly. So one thing that I always do when fitting seats is just check that this setting mic here zeroes out perfectly on the body of my Centronic, which it does. The zeros line up perfectly. If the camera's pointing that out, I don't know if it is. So what I've done now also is worked out what this cutter needs to be set to. So I'm going to back the setting mic off to that, which in all fairness I need to go and double check it, and it's 732 thou. So that's 700, 25, 30. We're going to release the clamp on the cutter. Bring that out to the size I'm setting it to. Nip the clamp up. And then just double check that I'm good on size, which I am. So now I'm going to swap this setting pilot over to the pilot for the valve guide, and what I do need to tell my customer is that I don't think he's honed the guide out yet. I don't know, I'm going to double check. It just doesn't feel particularly nice in there, so I'm going to have to just warn him about that as well. So I'm going to screw that in, and then I'm going to level off the bed of the seat cutter and then see what this cuts like. So the two Harley cylinder heads are now complete. I've got the seats in for my customer Dave. I'm waiting for him to just come because I need to speak to him. So basically what's happened with these cylinder heads is we've removed the original seat for him. He's then taken the heads back and he's trying to get into doing these few jobs himself, which I don't blame him. But he's removed the guide, he's refitted the new guide, then he's come to fit the seat. And he's struggled to do that because when I've measured the bore in the cylinder head and the OD of the seat, the outside diameter of the seat, it means there's a 10 thou interference fit. Well, it doesn't matter how much heating of the head you do and freezing of the seat, you're not going to get that 10 thou interference fit to work. So I've mounted it onto the seat cutter, I've put in a boring tool, measured the OD, measured the ID, set the tool up to bore out the cylinder head, and because the new guide is ever so slightly off centre to the original guide, which was the one that probably fitted the seat, it means that it was trying to take more material off one side of the bore than the other side, which that isn't a problem if you've got plenty of material there. The problem I've got is to get the interference fit that I want means that I'm taking probably 1/3 thou side off the bore to get my interference fit, and 1/3 thou is the thickness of a human hair, just over, so there's not really enough spec for me to do that. So when I've bored it, I've bored it and it's okay, it's good, and I've ceramically glued them in, but ever so slightly there's probably the width of my finger, like a line where it's not bored all the way through. I don't really like that. Now I'm going to let my customer know, because I think if he wants to do this again, he's going to have to go about it a different route. He's either going to have to supply the seats, leave the guides in, and let me do it all as one operation, and then he can finish it off, or he needs to get a seat which is like, even if it was 20 thousandths bigger, it would mean that I've got enough to bore to. So, but there we go, that's another job done. I'm now fitting the seats into the TWR head. We've been prepping up for putting seats in these TWR V12 Jag cylinder heads. I've been honing out the guide, so I've been using the guide gauge to see how much it's got to come out, and that is set to the valve at the moment, so it's 1/2 thou tight, which if we check with a valve, so basically what I've done here is we clamp 2 brand new valves in here, and then that sets the size for setting the gauge up. So I've already done that. I will go through that another time, but if I get another inlet valve, if I've set that gauge up right, this valve won't fit in this guide. Yeah, it won't, that's it, we're tight there. So basically I'm gonna use my diamond hone to remove the material to get that to size. I want about 1.5 thou clearance, roughly 2 thou, no, 1.5 thou on the inlet. So that's one job that I've done. Another job what I've done today is to machine down these bearings. These are for a Duratec. We have to reduce the radial thickness of the bearing, and then I've got to counter bore it and deburr it. That's for 2 Duratec race engines that we've got in. And then while I'm doing that, Sam has been flat out trying to get the actual workshop office done. So he's done the woodwork, he's started plasterboarding it up. There he is, looking all sweaty and workified.
Insulation's very warm.
Oh, he's been putting insulation up and the light circuit. So this is quite a nice size workshop office for when we're done. I've got to lift a bit of plasterboard with him, so I'll go do the plasterboard. So I'm back working on these V12 Jag heads today, and basically I've already fitted the exhaust seats, and they're a little bit low. And the reason being is some of the combustion chamber parts are low. So I measured the shallowest one and fitted and bought the seat for that setting, which made the seat sit low where some of the combustion chamber is high. Now I thought it didn't really matter, because the specs for the seats that the customer has given me, he wanted from the tip of the valve to the spring seat base, 39.5mm on the exhaust. I'm working on the exhaust, by the way, so that's what I'm talking about. Well, I've done the inlet and the exhaust, but it's the exhaust that I've got to change. So 39.5mm on the exhaust and 38.5mm on the inlet. So I set the spring seat to valve tip or valve stem tip to 38 and 39. And what I thought that would do was give us half a mil where we could drop the seat in lower if we needed to go to that. That meant it had quite a nice seat on the seat, and this bit of step could be blended in when they finish the combustion chamber. So my customer's taken it away, and well, that head down there actually, not this one I'm working on, and was working out the tappet clearances or the valve clearances and the spring seat or spring pressure or the seated pressure for the springs. And basically we need to run the exhaust. Well, they've given me all the settings that they've got, but the exhaust needs to be at 37.5, so we can get away with putting a taller seat in it by 1.5 mil, which is what that step is. And the inlet needs to be dropped into 38.4. So their 38.5 was pretty close, but 38.4 would stick it right in the middle of the range for the shim to set the valve clearances. So I've dropped that head down to 38.4 on the inlet. That one that's at 38, so I need to take 0.4 off that to get that right. And then unfortunately I've only just put them exhaust seats in, but I've got to take them all out and put a deeper seat in now so I can get my installed height at 37.5. It seems like a lot of work, and it is a lot of work. I mean, I was on them heads for about 2 days getting them where they were. Their calculations are slightly wrong, but this is all part of development, unfortunately. So the good thing is now we know that when they use that valve with that cam, that bucket, and we can use that part number valve seat, we drop them in at that height and that height, and it's bang on where we need to be. So all I've got to do now is just keep removing these valve seats. I've got 3 of them out, so I've got another 3 to take out on this head and all of them to take out on that cylinder head. So another job that I thought I would show is this Vauxhall XE, which is coming for rebore, hone, block skim and build it up into a short motor for a customer. Most of the work's been done by Sam, but I thought I would just show this because we've got to repair one of the threads, and if you can see here, someone's had a go at it before and made a right mess of it. And when you look inside here, that's the bottom part of a helicoil that you snap off once you've installed it. So that's just been left in the bottom. But what all these XEs suffer with is the silicon. When some people build them, they build them with quite a lot of silicon, and then it finds its way into the bottom of the stud hole. And then what can happen is when you originally put the silicon on, it's not so much of a problem because it's still soft. But if it comes back in, that silicon is then set hard, and then when you tighten a bolt up again, well, the silicon has got nowhere to go, and you keep turning the bolt and turning the bolt and turning the bolt, and then it either blows the bottom of the block out or cracks the block. There's a tiny little hairline crack there, but I can sort that actually. I'm going to put an insert in here to seal the hole, and then all this cap here is siliconed in anyway, so that won't cause a problem. But I can't get to the bottom, and if you look, it's all dirt and old silicon in there. It's all red, coming out red silicon, and once again more of it. So all of these holes Sam will clean out. Now this is something that is easily missed, but if you're building your own engine, just pay close attention to it. Some of these, the hole goes all the way through, so it's not too much of a problem. We will run a thread chaser down there just to make sure, but that one's a blind hole, and once again I can work all of the silicon out of that. So there's a bit of prep work to do on the bottom of this. Right, for me to repair this hole, I can see that there's still part of the original bolt there, and someone's drilled in it at an angle like that. That's sitting flush against there, look, and that's the angle someone's had a drill in there at. So that's not really very good at all. So what I'm going to use, this is actually the dry sump pan off Russell's blown up Vauxhall, but if I bolt this down, I don't have to bolt it tight, but if I just triangulate 3 bolts like that, I can then use this as a guide for drilling. So some use has come out of Russell's blown up sump. Russell's got a brand new sump, so this is just going to go in the bin because it's actually broke down here. It's quite difficult to fix this, and it's got a crack here somewhere where it's got a big one there. There's a crack there. Yeah, anyway, I don't know why I've gone off topic slightly. So that's ready for me to drill now, so I'm going to get a drill. I'm going to bore down there first. Hopefully that will loosen off the old bolt, and then I can replace it with a time cert, and a time cert at the back there as well. So the first job for me to do was to get the old bit of broken bolt out, whatever was left in there, to see how bad they have offsetly drilled this hole. And there we go, I've got it out. That's what was left in there. So you can see on this side, I don't know if the GoPro's picking it up, but on this side there's still thread in there. This is an M6 hole, so it would normally naturally come around here. So all of this here, all of this around here is where they've made a mess of it, quite frankly. So I now need to try and repair this here, so then I can put a new M6 hole there. Not quite sure I'm going to do that, so I'm going to ponder on that for a few minutes to work out a better way of going, because I think if I was to try and drill this back to the centre, this is probably going to need an M10 or an M12 putting in there to repair it. But I'll have a think and I'll show you how I get by it. So I'm just going to get the tap going, and then I'm going to check that I'm level. Because as soon as the tap starts, you can correct any sort of angle on the tap. So once again, I'm just going to eyeball it all up. And like before, it's very important to just keep the tap moving backwards and forwards. And once I've got this where I can just feel the bottom, which is now, I'm going to change it then for a plug tap, so I can get right down to the bottom of the repair. So once again, I'm going to just clean all the swarf off my tap, switch it over for a plug tap. And what I'm going to do is I'm going to run through the complete bottom of the block to see if we can just clean up any of the old dirt and instant gasket. Ooh. Just turn the music down, I don't want to get any copyright infringements. See, now it's forming the rest of the thread that the taper tap didn't get to. That's the bottom of that one. So once again, I can just spin that out. and the bottom of this tap is filled with dirt from that second hole. These ones are just open holes, so these are clean out, nice. But we might as well run through them while we're here. That's it. So this is all ready for honing, a bit more prep work inside. And what I'm going to do is that hole that I've just cut, I'm just going to put a nice little chamfer on it just to match these ones. And then the final test for it is we'll see if that sump screws back on and that my stud hole lines up. Hope it does, should do. Try that thread in there again. It seems to, the bolt seems to go a little bit tight. Might be where I've just deburred it, but just run this down again. Hopefully that's good now. Once again, I'm going to put a few screws in just so I know that I'm getting all the way round. That's it, I've got 4 screws in the dry sump, and then hopefully with a bit of luck this one will screw into. Yeah, there we go. Perfect. And there we go. So you probably could see how offset that hole is. So how I repaired this, because the hole was in like that, once I got the rest of the broken thread out, there was still some thread here, so it meant that repairing all this here was going to be quite tricky, and I didn't want to put any heat in it. So I've drilled and tapped it out to an M12, locked an M12 bolt in there, and then drilled the new M6 in there using that dry sump as a guard. So what I'm going to do now is just tidy this up. The Loctite would actually run into this crack as well, which will help this crack not well, I mean, it can't get any worse than what it is because it's pretty bad, but because it's inserted it can't get through there because of the full insert, so I'm not too worried about that. And like I said earlier, this happens when you put too much silicone on the bottom of these engines. The old silicone dries in the little cavity that's left from below the M6 bolt and the bottom of the threaded hole, and then when you build it again and you put more silicone in it, it's got to go somewhere, and it normally tries to blow the side of the block out. But there we go, that's a good repair, I'm happy with that. So what we've got to do now is hone it, give it a good clean, get all these bits of rust out, wash it again, and then that's ready for assembly. I'm going to go and try and get all these bits of metal out my finger now because it's stinging.